volunteer?
Tommy. Thank you,
Tommy, thank you so much.
Are you going to be in the Etherpad? Because then other people can join the Etherpad. Okay, so if anybody feels like they're bored during this meeting, help Tommy scribe in the Etherpad.
Right.
Um,
And if the Etherpad dies, just create a Google Doc or something and then put a link in it to the Jabber channel. Maybe just create a Google Doc and put it in the Jabber channel. Maybe we should just give up on the Etherpad. Is that a sound? Okay. Do what you think is right. Tom, we trust you. Thank you. So
do we have one of those unicorns that make the sound in the room?
oh, yeah.
Can we have that for this session?
No. Oh, that was Kathleen. That's right. So we have ACM.
Yeah. Well, we have whether anybody still has any discussion need on the invariance, which I don't think is the case, but we could
checkpoint that real quick.
Yes.
Okay. And ACM and it's been taken in a few time issues, but nothing else, right?
I don't think so.
Okay. That's what I have, so. How you doing? We do?
Well, not it's
We
not
have-
DTLS often. Check. Oh,
Mike.
whoa.
This one's hot.
It's working on the layering and the design of stream 0. It's specifically not working on DTLS. It is a closed design team.
you know that's next.
No, the closed design means closed. Yeah. Are we going to speak about stream bit at the beginning or later?
Most of the time.
Well,
there's a small-
ECN is first. So we're gonna ECN is first.
Okay.
That'll be 10, 15 minutes probably.
Probably.
And then we'll go to schedule.
So we have time to
Yeah.
listen to the start of the comes.
Yes.
We give 10 minutes for ECN first.
This is us, right? Where do we have 3?
Because I asked for an extra, because we ran out
Oh,
last.
nice. Okay, cool. Prepared. I'll go ahead and start these.
If you go.
Yeah. Although honestly, it's not half as full as last time.
No, I would actually wait on it.
Let's hold one back.
I mean, did you realize today was the first day, like in forever, where I click on GitHub in the morning and there's not a single notification on anything that happened?
Clear. Maybe think about what's broken.
Yeah.
That's interesting. 'Cause
That is,
Mia Kulivan, remind me, is there now any indication in the handshake that ECN is supported or not? I mean, like that you can actually send feedback or not. That's the part that's interesting.
I mean, if you receive, the idea is that if you receive ECT marked packet, either it's ECT0, ECT1 or CE, then you should use that ECN frame to feedback that information.
So basically what you're proposing is that you do some probing at the beginning of the connection,
Yeah.
instead of just telling you what you already know. And just like, if you're the receiver and you know you cannot access the bits, you could just tell the other end, right?
Yeah, I believe the idea is that if you don't have support, for instance, in your stack to being able to read and write the ECN bits, then you don't send, then you don't set those the ECT bits in the IP header.
Yeah, but the other end, the sender needs to know if the receiver can access it, the information.
Yeah, and but if the receiver doesn't access it, then it doesn't. Then it will be feedback normal ACK frame instead.
But I don't understand why you don't just provide the information. Why do you have to test it? Because that's something you actually know. Why do you don't tell? Because you do know it.
Well, that could be a discussion. I believe we wanted to make it as simple as possible without any flags or whatsoever. That is the. I know we had a sort of very early version where sort of had this extra negotiation stuff where it sort of indicated the capabilities, but.
So I mean, testing is definitely more complex than just telling the other end. I understand that you have to test anyway because the path might be not supportive, but it can still give you an advantage that if you already know that you cannot use it anyway, you don't have to do the testing, right?
Yeah.
Magnus Westlund. But I mean, it's really not testing. It's actually just trying to do it. If you don't get any response back, you can just stop marking the packets as sender side, and that's the whole procedure.
Yeah, exactly.
Yeah.
Right, so there's a wiki page in the base drafts repository that has the details of the proposed PR. It's not a PR at the moment, so I guess the ask is that people review that. I think in terms of the design team that we had to look at ECN and QUIC, this is sort of their proposal for what they believe is the best way forward, and now we're basically trying to figure out whether this proposal has, enough consensus that we can continue it in a PR. Make sense, Mirja? Okay. And I think it probably, so how close are we to landing 11? So do we have a timeline for landing 11? Martin is sort of looking like any day would work, huh? Okay. So the question is, when do we want to see a PR? Do we want to see this in 11? Because it feels like then we need to give this some time. Do we want to do this in 12? 12?
11 already has the long header changes to be a variable.
Right. So Ian is saying 11 already has a bunch of long header changes and other things, and there's also 10 that we haven't implemented yet. Okay. Quick segue. So I think since we're on the topic, so I think we're going to do 11 pretty soon. 11 and the now final version of TLS 1.3 will be the basis for 5th implementation. Correct? And we're going to probably do 5th implementation online as an interrupt day between now and Stockholm, and I'm guessing in Stockholm we're still going to do 5th implementation draft? Okay. Yeah. I don't expect to have any time after spin. I'm saying it now. Okay, so basically, this will probably then not land before, or at least there will be no expectation that it will be implemented before June. Okay, that gives us some time to review this. Edgar.
So Lars, I don't know what the other implementers' plans for 1.3 are, but we're not planning to ship with the RFC version number until the RFC issues. So it would be 28, it wouldn't be
Okay,
RFC.
so, yes, I misspoke, but so there's 28 will probably will have editorial changes unless
Yeah,
there's
it
some.
should be
yes.
mechanically the same except for the version number. But
Got it,
as I say,
yes.
we're just not planning to ship it in Firefox till like there are RFC issues because like we can't take it back.
Yeah, fair point, I misspoke. So we're gonna do 11 and 28 until 28 becomes an RFC.
Mia Kulevan. I just wanted to make one more comment. So the testing part is actually not QUIC specific. That's actually something that could also be applied by other protocols. So I'm wondering if you want to have it in the QUIC document or if you want to have it somewhere else, or if you maybe want to have something very simple, like simple default testing in the QUIC document, and then we could think about more advanced testing somewhere else as well.
Maybe one comment from me. I believe it could be good to have something in the QUIC documents, and maybe because I believe many people doesn't read the other documents in other areas, and
Yeah, I would, so as an individual, suggest that we try and have something self-contained in the QUIC documents so that the QUIC implementer can read that and implement it and not need to read histories of ECN that we've had in the IETF in the past. Martin?
Yeah, so Martin Thompson. I'd suggest, timing-wise, spend a little bit more time polishing this. I noticed a few grammatical things in here and a few questions. It's a little bit easier to iterate on the wiki than it is to iterate on a pull request, and for something this large, pull requests tend to take a little bit of time, and it'll rot if you make a pull request, whereas this won't rot. So get it good, and once we get 11 out, it shouldn't be that much longer. I don't know how long we're going to sit on 11, but we have a couple of issues to talk about today. Maybe we'll try to roll some of those into 11, but I anticipate weeks, not months.
Yeah, and if we're not planning on implementing anything like this for Stockholm, we can actually take a significant chunk of time in Stockholm if we still need it and finish it, and then get it into PR form.
So the only reason, well, so I fully anticipate that people won't be implementing this even after it's in the document for various reasons, right? It's difficult for people operating in New Zealand to put the markings on them, whatever else. So, and people just are slow, right? We take ages to, we've got a whole bunch of work to do. So.
It's actually not hard,
Well,
but it's work.
Yes. Yeah, but it's work. Yeah.
But yes, so it's not something that's sort of critical for V1.
Jana Engar, I want to second Martin's opinion. I think this is useful, good to have, and we should make sure the text that we have on the wiki is solid, and we will get it in. There's just no urgency because I don't think any of the implementers are going to rush to test this yet. So we can get to it, and we should get to it, and we will get to it. But it's okay for us to wait until at least 12.
Okay, then people should please take a look at what's on the wiki and talk to Ingemar and the other folks on the design team. I think there's a list, so if people want to really get involved, you can talk to Ingemar and you'll be put on the list, I'm guessing. But the goal is to sort of keep hashing this on the wiki and then get it near a PR by the June timeframe with the understanding that it may not end up in 12, but it will end up in a version shortly thereafter. Thank you.
thank you.
Okay, Brian? So what we're going to do here is Brian will give a presentation. It's okay, Brian. It's safe. It's safe.
Don't overpromise.
I have a whole interpretive dance for later. So.
Brian's going to give us a presentation. We're going to ask for clarifying questions afterwards. Then we're going to move into a discussion phase where we talk about whether the working group wants to address this use case and whether this is the right way to address it.
Yep.
And then we're going to do some hums.
And I'll note that there's a bunch of stuff in backup here, so I may be
may call
throwing
on
slide references up during the discussion.
Sure. Let's go.
Just sort of foreshadowing that we will probably ask everybody to be very short on the microphone because I expect the discussion to take a while?
I'm not putting that in my computer.
Okay.
All right, so.
I can take it directly.
So try and make your point as short possible as time. You can go back into the line. You don't have to say everything the first time you make it to the front of the line. And we will try to time manage this pretty aggressively if we have to.
Right. And one more bit of context. We've been talking about this for a while. Our intent as chairs is really to try and get a direction on this and get us something we can confirm on the list today. We're getting to the point where we can't stall this decision much longer. So please keep that in mind in the discussion. We're trying to get to closing this issue in some fashion.
And the reason, we specifically didn't schedule this discussion at an interim because we wanted to have sort of the broader participation that we would get in the general IETF. Right? That is the reason why we didn't do it in Melbourne, for example. But this is, so we've kicked this around long enough, and we really need to decide what we want to do on this topic so that we can sort of move on and free up a bunch of cycles for a bunch of people.
There you go.
Take it away, Brian.
Hi, I'm Brian Trammell. I'd like to see a show of hands. Who here doesn't know what the spin bit is? Wow, okay, so there's a lot of instruction here that is actually going to be useful for like 6 people. Great. Next slide. This is in a PR 1046. Basically what we want to do is we want to take this little red bit right here from the QUIC short header, and we want to make it spin. There's a very simple algorithm for this. Every time the server sends a packet, it sets the last spin it saw on the packet that it sends. The client, thank you very much. The client sets the inverse of the last spin it saw on each packet that it sends. So what this does is a very simple distributed algorithm. It creates a square wave that's on this one bit that's visible on the packets in the flow with a period equal to the application experienced round trip time. Why do we do this? So we're preparing for a post-TCP world. We've seen in MapRG anywhere between 5 and 7% of QUIC. I've heard on some links that the amount of QUIC is much larger than 7% of the traffic that's crossing that link. There is the ability, based on the information radiated off of TCP, to do lightweight, efficient RTT estimation on arbitrary aggregates of traffic. As QUIC traffic replaces TCP traffic, this visibility goes away. We got a lot of use cases enumerated in the spinbit draft channel QUIC spin 01, basic intradomain troubleshooting, home network troubleshooting, buffer bloat mitigation for mobile networks, which I actually want to note that in the hackathon this week, we actually built a real buffer bloat mitigation simulation or emulation that shows that this actually reduces RTT for all of the flows over some of these links significantly. And internet measurement research. How does it work? I'll do the slides versus the interpretive dance. I can do the interpretive dance later if it's not clear. The client starts sending, once it starts sending short packets with short headers, it puts spin 0. The server basically just reflects spin 0. As soon as the client starts seeing spin 0 packets, it sets spin 1. The server reflects back spin 1. The client sees that spin 0. So basically you see all of the packets in flight in the flow kind of pulse between spin 1 and spin 0, and the period of that is the RTT. So how this works if you're doing unidirectional one-point measurement, so the observer is at this point here, the observer sees some zeros, and then it sees some more zeros because the zeros are on the backside. It shifts to 1, you see the edge, boom, and that square wave is the round trip time of the flow. With bidirectional one-point measurement, you can actually compare the square waves on the upstream and the downstream side, and you can separate the components of RTT. So you can know how much of the RTT is attributable to between the observation point in the client and the observation point in the server. Does it work? Yes, it does. Our student Pete DeVere has implemented this in Mink. We've actually had 3 other implementations of this at the hackathon. The implementation effort is trivial. Basically, so Pete's a pretty smart guy, but he'd never seen Go and he'd never seen Mink. And within the first 45 minutes, he had a working spin bit. It took him another couple of weeks to get Mink running, but the spin bit was actually spinning. The spin signal, you get really high resolution information about the RTT experience by the endpoint applications. One of the things that surprised us is due to ACK timing and QUIC, the information that's available at the receiver from the spin bit is better than the information that's available in the ACK stream from the spin bit with respect to the RTT. You get more RTT samples from this method. Does it work in networks that are not perfect? Yes, it does. The signal will start to overestimate RTT slightly when you see heavy loss. And when you see reordering, you get some loss of fidelity where you get edges back and forth.
This is a clarifying question.
Yeah, I'm
right?
just trying to read the slides. I'm sorry.
Sorry.
Well, what about? Can you just go back and tell me what I'm looking at?
Yeah. Oh, so, all right. It's difficult for me to point from where I am, so I'm going to have to leave the
You
pink
can leave
box.
the pink box. You're released.
You can take the mic off the stand too.
Oh, yeah. Right.
I mean, you don't have to. You can just...
Yeah. Okay. So basically, the spiky orange stuff here is, so what we have is a client connecting to a server and uploading data, right? So it's the reverse of the way that this usually works, but you can just switch the things. This is the this is the spin bit information available at the sender side, and the moving minimum. So this green line underneath here is there's just a minimum filter, right? It's like the linear smoothing filter that TCP uses, right?
Okay.
So like the unsmooth TCP RTT is spiky like this as well. Down here, this is the server, so the data receiver side ACK stream information about its RTTs, and the green here is the moving minimum. So you see the resolution is lower.
And so you don't have a picture that shows the true number.
The true number. Okay. The true network number in this case is 40, and then it goes up to 80.
Oh, okay.
Yeah.
Okay, perfect.
Right.
Thank you.
Oh, yeah,
Okay.
yeah. So this, this edge here was making sure that it responded to changes in the path RTT.
And just so I understand this clearly, because this is in the clear, exactly the same information is available to an inspection endpoint on the wire.
This RTT information is what's available to anyone who can see the packets.
Okay.
Right. Yes.
And I guess why is the server and client different? I'm just stupid today.
I actually have forgotten why this was. So it's basically because of how I think it's because of how ACKs are called. Maria, do you want to answer that question?
Yes, so the traffic is flowing from the client to the server, so you have a lot of samples, a lot of packets, and from the server to the client, you only have ACK, so you just have less packets, so it's like less accurate.
Right.
And so what does the network inspection point see?
So the network inspection point sees this, right? So it sees the spiky yellow stuff.
But sorry, that's my question. I guess what I'm trying to wrap my head around is if the perspective is different from the client to the server, and the inspection is then points in the middle somewhere,
right?
What its estimates look like?
It gets the better estimates.
Okay, thank you.
So in the world with the current -10 version of the draft, the packet numbers are still in the clear, so it's very easy to use packet number information to reject reordered edges and to detect loss and to reject edges where there's loss. So if you have packet numbers that increment by 1 per packet and are in clear text, then this signal is very robust. If we encrypt the packet number, we can talk about that in the backup. Yeah, in conclusion, we've spent about a year talking about this. We've spent a few months implementing it and getting experience with it in real networks as well as in emulated networks. So Pete has a stack of paper about this big filled with plots with various sort of loss and reordering models. It turns out that this actually gives you pretty good RTT information all the way down to the point where you drive the transport protocol into the ground. We actually had to disable flow control and congestion control in order to keep it to keep sending packets in order to look at some of the points in this network impairment space. It's minimal overhead. We have 1 bit. If we're encrypting the packet number, we can talk about other options. It's very high fidelity. It's an explicit signaling approach that replaces an implicit signaling approach. It has minimal privacy impact, as we saw from the RTT-DT in, was that Prague or Singapore? Yeah, so from a while ago. It does what it says on the tin. It replaces on-path visibility into the RTT in a world where we're moving from TCP to QUIC.
So I think we're still doing clarification questions.
Yeah.
So tell me to go away if you don't think this is clarifying. Does this change at all when we do multipath?
It depends on the multipath architecture, but basically this would be so per subflow. The spin state would have to be kept on a per subflow basis in order to get it to work. If you're mingling the spin state among subflows, then you're not going to get a usable signal.
So subflows would have to be visible in the clear in order
well,
to...
so the subflows are going to be... No, you're not, you do not, yeah, no, you do not have to link the subflows in the clear in order for this to be useful, because you're basically, what you're measuring is the network RTT of the 5-tuple. So...
Ian Sweat, Google. Did you have any numbers for, like, you said you kind of drove the transport to destruction.
Right.
Did you have any numbers for how it degrades as you go to numbers like 5% and 10% and 20% loss? Because we do occasionally see numbers like this, and I wouldn't want it to go totally haywire.
So, so are you talking about 20% random loss or 20% burst loss?
That's usually a packet policer and...
Okay, yeah. So when you see burst loss, it goes from sort of the gray line here to the blue line here. You get essentially overestimation of the RTT because you're just missing the edge, right? So yeah, the edge that you see is delayed. There are so the edge bit and status bit things here. Actually, you know what? I should probably explain those. So these are things that we started looking at in order to prepare this to be useful in an encrypted packet number world. The status bits essentially reject all of the edges that are lost. You can also do this with packet numbers, and then you get basically up to the red line. The reason that the red line looks better than the vanilla without loss line here is it's actually rejecting some of the edges that are farther in variance, right? Like, so when you start rejecting lost edges, you get fewer samples, which means your variance goes down, so you get less this error.
Okay, so follow-up clarifying question that you just made me realize. So vanilla without loss is with the packet number, not encrypted as QUIC is today?
So vanilla without loss is actually without looking at the packet number.
Oh, okay, thanks.
Yeah. So if you have a good, if your network is running well, you don't need to look at the packet number. You can basically just look at the raw series of edges, and you're going to have few enough of those are going to be offset or lost that it's not going to affect the aggregate that much.
Ignacio Álvarez Amelín, fellow IETF. My question is why you say that it overestimates, just because if you lost the packet, you
get an edge later.
Okay,
so
but,
the RTT,
but normally,
the RTT estimate goes up because the edge is delayed.
Okay, but normally you need so much chance to lose exactly the packet in the edge.
Right. So you get one edge per RTT. So yes, you do have the loss rate has to go up to around 1% before you start losing the edge packets, and of course that's BDP dependent, right? So.
Yes, it's not so much.
Right.
In one case. Okay, thank you.
Colin was first on the back mic.
Hi, Colin Perkins. 2 quick clarification questions. Have you run into any issues with reordering in very low RTT where the signal gets scrambled?
Yeah, looks like this. So basically what happens is so with very low RTT, we did pretty much everything with 40 milliseconds. That was sort of the baseline. Yeah. With lower RTT, you actually get less absolute error because if you do like a single edge reorder, you just get, a spike of 1 back to 0 and then back to 1. You get an RTT measurement which is pretty close to 0. It's the inner packet time, right? With 40 millisecond RTT, if you have a fair amount of, so there's vanilla without reordering, which is sort of the gray line that's underneath all of the other lines. If you start reordering it, you end up with a lot of these very short RTT estimates. It turns out like a really stupid heuristic is just to reject everything that is unrealistically short, and this was a static heuristic, and you see it reduces the error quite a lot. So 2-bit spin and some of the valid edge stuff that replaces the packet number when the packet number is encrypted rejects that. You can also, you get back down to vanilla if you're rejecting based on packet number reordering detection.
Sure. What do you consider unrealistically short? Have you thought about data, data centers, for example?
Unrealistically short heuristics would be like, so you take the expected RTT, and I think it was divided by, if it's like less than 1/10, right? It was a multiplicative heuristic.
Okay, but it doesn't break in a data center where you're.
Well, you would just take your tiny RTT and divide it by 10, right?
Okay.
Yeah.
Yeah. Okay. This is only for short header packets, right?
This is only for short header packets, right? The idea is the long header packets are one, you have the handshake. You can just basically do your handshake RTT estimate the normal way. 2, you don't have many of those packets. 3, what we really, the point of this is to create samples of the RTT, either that you can use for a running time series analysis of a single flow if you're doing diagnostics, or if you're doing baselining or measuring, you're going to take these RTT samples and you're going to put them into an aggregate and you're going to watch them move together, right? So the long header, it's not at all worth the complexity to add this to the long header.
Just a reminder, we're still on clarifying questions. Yep. Christian.
Brian, when I look at your numbers here, I have some kind of fear, and the fear is that this spinning bit measurement will work very well if the network is working well, and will start to work less well if the network is having problems. And I am concerned that this kind of behavior goes against the idea of having a measurement tool that tells you some information when you have a trouble.
So thank you for leading into one of my backup slides. So this is an enhancement that we looked at called the edge valid signal. So what happens here is that okay, first of all, I'll say if the packet numbers are in the clear, the entire path has enough information to detect upstream loss and reordering of an edge. So it has enough information to determine completely whether an edge is good or not. When you have heavy loss and heavy reordering, you tend to get many fewer samples, but for any flow that is able to keep, if the network conditions are such that the flow is able to keep sending, we've never seen a situation that we have to drop all of the samples, right? We still have visibility into what's going on to that flow. The sample rate of that flow is itself, like the number of good samples versus the bad samples, is itself an indication as to how much network difficulty that flow is seeing, right? With the valid edge signal, which we looked into more because it looked like we were moving toward consensus on encrypting the packet numbers, so we spent some time looking into this one. With the edge valid signal, there's a counter that goes, it counts up 0, 1, 2, 3 every time an endpoint sends a good edge. So if an edge gets reordered or lost, what the measurement point will see is what looks like an edge because it went from 0 to 1, but the endpoint didn't think it was a good edge, so the valid edge counter is at 0. So it will say, okay, this is not a valid edge. So you can easily reject, you can encrypt the packet number and easily reject edges just as well as if you had the packet number if you add 2 bits to the signal.
So
what we saw in this case is we had to, like I said, we had to disable flow control and disable congestion control and send at a constant rate in order to get it to keep generating traffic at some of these points in the space, because we were doing like 10 millisecond RTT with 10 millisecond jitter, so random packet delivery order. The transport falls over at that point, right? The diagnostic is the network is so screwed up that the transport stops sending, right? So we shared your fear when we looked at this originally, but we have a fair amount of data that at least I'm less afraid. Pete's thesis on this should be published in about 2 weeks, and we can send that to the list.
So my simple brain has a simple understanding what you said, and I'm going to summarize. Summarize is that if we have a combination of the spin bit and clear text packet number, we are fine. If the packet number are encrypted, we need a couple more bits with the spin bit.
Yes.
One.
Two.
We need one more.
Well, okay. So with an encrypted packet number, a 3-bit spin bit is indistinguishable from the 1-bit spin bit with a clear text packet number. There is another enhancement. This is courtesy
clarifying
MT.
question?
Is this still clarifying, or can I keep going?
We need to start clarifying right now.
Okay. There's another enhancement where basically you have a 2-bit spin that counts up 1, 2, 3, and anytime so the endpoints, of course, know that an edge is valid or not because they have access to the clear text packet number. So they know whether or not an edge that they're seeing is valid or not. You can use this that spins 1, 2, 3, and then takes an additional code point 0 that it sends for an entire half RTT to say, the last edge that I sent was bad. So measuring this is a little bit harder. We have not yet shown that it gives you data that is as good as the 3-bit spin, but it's in the ballpark.
Thank you.
Igor Lubashev, Akamai. We're discussing RTT measurements, but did I miss it or we didn't get to it yet? Characterizing loss and loss patterns using spin bits without a clear text packet number?
So that's out of scope for this discussion.
That's out of scope for this discussion. May I push an idea though?
Briefly.
The edge valid we haven't done the work yet, but we have an intuition that the series of valid and invalid edges will give you some basic information about loss or reordering. It won't give you information about which it is, but it will, if you see sort of the valid invalid edge series, you can derive some information about loss and reordering from that. We haven't done the work yet. That's future work, but it won't give you information about very low loss rates. Like if your edge loss probability is below a threshold, you don't get any loss information. But if your loss probability is high enough that you are losing edges, you will see that in this 3-bit signal.
I don't think so.
But this is not the goal of this proposal. It's a side effect.
As a clarifying comment, I plead with you never again to say 3-bit spin bit.
Okay. Okay. So what we were.
It's a spin nibble almost.
Thank you, Ecker. So this is a spin bit and a 2-bit valid edge counter, or VEC, is what we've been calling it.
Marco Goyo, this is a very basic question. Is there an assumption that this requires continuous flow of packets to work?
For the 1-bit spin bit, hold on, do I have that in the? For 1-bit spin, with or without packet number, if the sender is application limited, then you will have overestimates, right? When the sender stops sending, you're going to get one overestimated edge at that level. The edge valid signal, if you add this edge valid signal, you can have a very simple heuristic at the sender side that drives the valid edge counter to 0 when it is sending an edge in reply to a packet that came in more than 0.1 times RTT ago, right? So the sender can expose whether or not an edge is likely to be valid through the valid edge counter. And that reduces all of the overestimation of bursty traffic.
Okay.
So the second bit helps you, but even if you only have 1 bit and you know that you're sending a traffic pattern that is useless to measure round trip time, you can just set the bit always to 0 and say, like, this flow is not helpful for you, because in the network, if you have enough other flows, you just need like general information. Right?
Yeah, so if we go with a 1-bit spin bit, there are ways to reduce overestimation from bursty traffic.
Eric Nygren, and does that bursty, in the multipath case, does that bursty traffic case become more important? Because it seems like if you're switching back and forth between which path you're sending things on, then you may want to be careful not to be having people observe stuff on, because each of those paths may look like it's bursty for some period of time and not bursty.
Can I reclassify that as a research question as opposed to a clarifying question? Yeah, I mean, yes, it seems like that. We haven't looked at it. We will.
Okay.
May I quickly want to add something? As long as you send enough, like more than, if you send for at least one round trip time, you get one sample.
Right. But if you're basically doing flow spreading where everything is designed to look bursty, then yeah, you're not going to get good signal out of this.
Clarifying question. I assume you have some map between the path and the RTT estimates to keep. What is the key for the map you're using?
So for all of this, the key for that map is the 5 tuple.
Okay.
One hopefully, Colin Perkins, one hopefully done clarifying question. This is in the clear but authenticated, so middle boxes come by
Yes.
the RTT games. Right?
Yes. Sorry, I neglected to say that.
Any other clarifying questions? Okay, well, thank you all for coming today.
And I think you've seen all the slides. Mark, you've seen all the slides now, so if there's one that illustrates a thing, you can find it. Right?
Yeah, and you can always help me.
Yeah.
Okay. All right, so now we're going to go into the discussion phase, the non-clarifying phase. So just to give people a little context, as Brian said, we've been talking about this for a long time. It's been somewhat contentious in the working group for a fair amount of time. Good positioning, Brian. We spooled up a design team to evaluate especially the privacy implications of the spin bit, a 1-bit spin bit. And the result of that was they came back and they said they couldn't identify any concrete privacy issues with a 1-bit spin bit. We had some concerns about whether the data generated by the spin bit was usable. Brian's just gone through the experimentation and the research that they've done around that. And so now we're in a position where the working group needs to decide, do we want to add the spin bit to the specification in some form? And so that's the scope of the discussion now. We're not going to talk about loss, for example, or other aspects of things that networks might need to understand about the flows. We're just restricting this discussion to the spin bit proposal and the use case that it tries to address. So, Brian.
Yes.
Do you leave the shape of the up to the chairs? No, sorry.
It's round.
Ted Hardy, I didn't hear the question, so I'm not ready to give a yes or no answer. But I am perfectly willing to say that having gone through the exercise with the design team on the potential privacy implications of this, that I'm pretty confident that the bang for the buck we're getting out of this is very good. The amount that this seems to me to leak compared to, say, the information already available on geolocation is just extraordinarily small, in my opinion, for the threats that we considered. And this does seem to provide a very, very useful set of signals. In particular, I'm very pleased with 2 design points here. One, that this is in the control of the sender. This is designed so that the sender does all of the setting, and all the server does is reflection. The advantage of that is that the sender remains in control of whether or not this is on. And although the receiver can decide not to reflect and just set everything to 0 as well, there's a good bit of agency in the right place, in my opinion. The other thing that I think is a very good piece of the design here is that there are ways, as we move forward into multipath or into other mechanisms, to continue to use this on a per-path basis, but it's not trying to be so complicated to incorporate all of the different potential measurements that you might do at once. It's clean in its one aim. So I'm definitely in favor of adding it.
Ted, before you go, because I know that's a high-cost operation, you said this a lot. Are you referring to, and everyone in the queue, I'd like to focus a little bit on, are we talking about the single bit? If we assume we're going to encrypt the packet number, how do you feel about the 2 or 3-bit solution?
Ted Hardy again. So I was actually evaluating in terms of the way Draft 10 currently has it, which has an unencrypted packet number. Having looked not nearly as completely at the VEC, I believe you're calling it, I believe it is quite similar. My intuition is that by encrypting the packet number and going to the VEC, we're actually making an overall privacy enhancement. But as I said, that's an intuition. I actually haven't done enough of the research to make that as confidently as I believe he has been able to make the assertions he's made today.
Thank you.
So by the time the tail of the queue is out of the room, we're going to move the front mic forward, just so you guys can stay inside.
I can move it right now.
Go ahead and do that now. Yeah, that's a good thing. We can see you better.
Daniel Kahn Gilmore, ACLU. So, I appreciate that this has been whittled down to a relatively small number of bits. I would prefer to keep it as small as possible. 0 would be great. If we're forced into having 1, I do appreciate the engineering work that's gone in here. I want to point out that it's not clear to me the discussion earlier was about bursty traffic as opposed to like a steady flow. There may be other traffic patterns where this doesn't work as opposed to flow, typical flows that we see today, particularly if we start looking at non-reliable streams that don't require ACKs. And it concerns me a little bit that we may be designing something that encourages network operators to make decisions about flow paths based on assumptions that we currently have about reliable streams, which may have a cost if we want to use QUIC in the future for non-reliable streams if the network operators are doing bad things to traffic that doesn't match what they think is the RTT estimate. So I want us to keep those ideas in mind. If you think QUIC is going to be interesting for non-reliable streams as well, think about what we might be doing to ossify the network stack if we include something like this.
Jana Iyengar, I actually agree with what DKG just said. I think it's important to consider what happens when the ACK rate goes down specifically. That is a significant value that we hope QUIC can provide. But I stepped up here to say something broader, and I will do that. I've basically spent the last year listening to arguments, and I've heard them from all over the place, and it has taken the better part of a year. I've spoken with many people, including operators, vendors, endpoint implementers about the incentives, benefits, and deployment stories for this bit. And I've considered all of these carefully. From where I'm seeing it now, we need to make a decision now, and I think of this as an engineering decision, not a theoretical one or not a research one. My informed opinion, based on all the conversations I've had and all the thinking I've done, is that we should not include this bit in the core specifications for V1. I'd be very happy for it to be an experiment that demonstrates that there's value and there's interest in deployment. I think it would be very valuable to have an internet-wide experiment that actually shows some of these things. And I think this mechanism is a great starting point. I think there's some interesting data here, but there are also a lot of open issues, as we can see. And as the design of QUIC evolves, that will challenge the assumptions that are being made in this mechanism here. And all of that points towards an excellent starting point for experimentation. But I don't think this needs to be in the core specifications now, and I don't think it should be.
Kevin Smith, Vodafone. So first point is I heard earlier in the week about QUIC being measured at about 9-10% on cellular networks. Certainly we've measured it much, much higher, probably 40 to 50% in many of our operations. And so a privacy aware or privacy compliant spin bit, which helps us track and monitor and measure that, is very welcome. To the extra bits, one driver that I'd like to put forward is 5G radio. So we want to, as that evolves, we want to get a feel for how that's performing, new wavelengths, etc. We want to see how transport protocols.
When you say extra bits, do you mean extra bits for the purposes of measuring latency, or extra bits for the purpose of measuring other things?
The VEC. So the
specifically this.
Specifically the VEC. Yeah, exactly. So that's our driver. Is 5G radio and how the transport protocols act over there.
Thank you.
Hi, Emil from Orange. So we implemented and pre-deployed the spin bit over our networks, and it provides us with enough information to be able to make troubleshooting with dichotomy, to know which side is the wrong side and which side is provides the right delay. So now we don't make any investigation with an additional bit. So this, I don't have any opinion.
So you used Mink or something, some other stack that was enhanced with a single spin bit, and you ran it in your network, and you validated that you got information out of it?
Yeah, we shared that
Okay.
during the hackathon
Yeah,
using MinQ, Minty, and that. Yeah.
Thanks.
Hi, Colin Perkins. So I think it's fairly clear that there is no meaningful information leak from having this bit. So from that point of view, I think this is worth including. I think if anything, there's too little information here, and I think we're going to. I worry that we're going to find it works in the cases where the network is behaving, and we don't have sufficient information to use it for debugging the difficult cases where the network is starting to misbehave. So I lean towards thinking this is worth doing. I am unconvinced it will turn out to be as useful as we think it is. But I think it's worth doing as an experiment. I think we should perhaps consider arranging the bits so that if the experiment turns out to be useful, it can become part of the invariance. Because if this is something people are building measurement infrastructure around in the future, then we want to guarantee that where it's going to be. But I'm not sure we're at that stage yet, and it's not clear to me that it will become useful.
Praveen, Microsoft. So we have a genuine use case today in the cloud where we want to measure what's happening with tenant traffic. And that we're doing that with TCP today. And having such a bit would be extremely useful to be able to continue to do that with QUIC. If we are looking at QUIC as a replacement for TCP, I genuinely think that this would be useful for us. The other good part about this proposal is that it's not compute intensive. So setting this bit is not a big problem for an implementation. It also looks like the implementation effort is pretty small. But as to the discussion of experimentation versus not, yeah, I mean, we could consider not making this part of the invariance if we want to, but putting this in version 1 would at least unblock the experiment and allow us to find out if this works well in practice.
Channeling Ben Kadek, Security AD from Jabber, who's in another room. He, I think, echoes John's point. Would it make sense to use a quick version to experiment with the spin bit, or are there finer grained ways to indicate that to the path?
Patrick McManus. Line's moving pretty well, that's good. So I will take issue on the other side that this does not leak any interesting data. I think what it leaks is obviously RTT, and when I mention that to people, they say you can get that out of the client handshake. I'm like, if you can get that out of the client handshake, why do you need the spin bit? Right, because it changes over the duration of the flow, and this is relevant in an HTTP world, which often implements request reply patterns of single messages in each direction, and we are building a protocol that is otherwise multiplexing and obscuring many of those interactions, and they can of course change over the lifetime of the connection for how long that takes. And the spin bit actually brings that fundamentally as a signal back into the clear, and I think that probably has some traffic analysis properties. So I actually don't think this is obviously harmless as it is sometimes presented. I guess the second point I would make is I think doing this is actually ossifying around the behavior of existing pieces of the TCP ecosystem for properties that TCP never delivered. You know, the fact that acknowledgements were in the clear is simply an artifact of TCP. It was not trying to signal to the network. Those are designed to be end-to-end signals. And I think making them end-to-end signals actually preserves our ability to innovate in all ways around that. So I'm opposed to any number of bits on those bases. And, you know, finally, with respect to, you know, my product, it's fairly unlikely that we would participate in this, this ecosystem.
Thomas Nokia. I think we have compelling evidence that this works, at least in some scenarios. I think for this to be really useful, we need first implementation to support this, and we have bad signal from Mozilla. And secondly, we probably need to make this part of the invariance. Otherwise, we can't rely on this to do the measurement. There was a comment about the fidelity of the signal in lossy reorder, with an environment with high loss and high reorder. But for example, the mobile network, you don't experience that much reordering or loss, but you have high variance in RTT, and this is a very, very valid tool to actually grab that signals out of the network.
Hi, Brian Trammell. While stating my general deep skepticism about the success of traffic analysis resistance in the internet, there were 3 issues raised. Actually, I didn't put names down, so I'm assuming Jana was one of them. Sorry, I'm picking on you because you're right there. So there were issues raised about the spin bit on partially reliable or non-reliable streams where there's no ACK stream back. ACK elimination, I don't want to say compression or coalescing, right? Because, so basically where the acknowledgement scheduler is using a different algorithm than the one that TCP is working right now. These are valid concerns, but I don't think they're a problem. Because as long as, so your sampling rate goes down, right?
That's the range.
But the sampling rate will never go to 0 as long as you have some sort of acknowledgement-driven congestion control. And if you don't have acknowledgement-driven congestion control, then you don't really have much of a network left to measure. So to Patrick's point, so basically as long as you have a situation where you will, during the lifetime of a given flow identified by 5 tuples, so these are not connections, these would be subflows in a multipath environment. We don't have to link the subflows in a multipath environment. All you need is occasionally a low delay between one incoming packet and the other packet where an edge transition would occur. In any flow that would contribute to measurement, you're going to have enough of these to generate samples, right? So if you're trying to use this on a non-TCP acknowledging flow to do per flow diagnostics, yes, in certain cases you might get the time series will have too many gaps in it for you to be able to see the evolution of the RTT. If what instead you're trying to do is aggregate these by link, so you're trying to do passive measurement of all the traffic on a link, and you're looking at residuals and you're looking at how that moves together in order to diagnose the link, you're still going to have enough samples in order to be able to generate some signal out of that. So in that future world, the applicability may reduce, but for the cases that we're looking at for sort of like network health, I don't see a realistic evolution of QUIC for which that would go away. With respect to leaking RTT, yes, of course, that's what it's supposed to do. If we don't want the path to be able to measure RTT at all, then we should not do this. I think that we do, obviously, because I spent about a year working on this presentation in one form or another. As far as the information that's leaked between streams, I want to dig into that a little bit more. I don't see it as a problem in that if you're doing multiple streams together, you're basically sort of obscuring the size and timing relationships of those streams, but you're still going to get this pattern where you're going to send a packet that's going to be an edge, and then you're going to get some sort of acknowledgement or thing back. That pattern, I don't see how that would expose it. Actually, Patrick and I should probably talk offline because I don't really understand his concern there. So that's everything I have, and I'm going to go back to the line.
Brian, before you requeue, because we know that's what you're going to do, just one clarifying question.
Yeah.
In your proposal,
yes,
this is always opt-in. The endpoints both have to opt in. So I just want to make sure that people realize that even if we put this in the invariance, it is not a guarantee that it is going to actually happen on the wire.
Yeah, and I would actually, so there's been some other discussion about the relationship between this and greasing. And for the common case where you're basically just trying to do generate some RTT samples so that you can look at aggregates, individual flows can probabilistically opt in or opt out of this. You don't need to negotiate it. Basically, if you have a probabilistic opt-in on either side, then you multiply those two together, and that's the probability that you're going to get a signal. Once you have the VAC, you can also probabilistically drop samples. You can basically say, here's an edge, I have a valid edge. I only want to expose my RTT. You have a target RTT exposure rate, and you can drop the valid edge counter in order to meet that target rate. So there's a lot of things that we can do. There's very fine-grained endpoint control for how much information gets exposed.
Okay.
And I think that for a greasing standpoint, if you don't want it to ossify around, you always get a signal. Otherwise, hey, this is not a quick flow. Then that probabilistic enablement is a pretty simple way to achieve that.
Sure. I was speaking of something slightly different, which is if no one opts in because of whatever.
If all of the opt-in probabilities are 0, then the number of signals that you get is 0.
Exactly.
Yes, obviously.
Yeah. Thank you. So it's 10:37, so we have a little less than an hour and a half, and we still have a very deep queue. So keep that in mind. Gabriel.
Gabriel Montenegro, Microsoft. Yeah, I wanted to emphasize the nature of opt-in, and Brian already did a much better job than I would have done on that. I would like to add, though, that we would definitely opt into that. I like the probabilistic nature of
Just so everyone knows, when you say we.
Well, in Microsoft, we would.
Okay.
With our browser.
In all of your implementation.
Yeah. So whether we would always do it or not, that's different, but we would definitely take part in this, and we think it's important. We see it's useful. The one very important reason why I'm saying pretty confidently, yeah, for this we would have support and interest is all the very extensive privacy analysis that has been done. I would like to see similar analysis going on for the VEC before saying anything about that. But for this one, I feel pretty confident it's fine.
Jahed from Ericsson. So I'm one of the guys like some who go to EA to WoW kind of thing, and because I have been following what's the discussion happening around SpinBit, and now that we have implemented it in hackathon and did some testing. I think Marcus is online, so he's going to talk about more about parts of that. So I'm more convinced like this is useful now. And looking at what DT design team had the output about privacy, I'm more okay with what it leaks, the RTT. I have worked with service providers, network operators, and they kind of see the point of network measuring RTT and making the network health keep okay. So this is useful. But I also think we should discuss a bit more about this unreliable mode, but having seen like what's happening around the IETF, like QUIC is kind of becoming the general purpose transport. You would like to do some media over QUIC, maybe unreliable, maybe partially will work. And I have my colleagues who believes like a similar kind of condition control could work for more reliable and partially reliable kind of transport. I don't see that's the big issue. But I do concern that if it is not invariant, if it is not in version 1, then we might not get the test we want to do. And as this is opt-in, I don't see this a big issue. So if it is in version 1, we do testing, we see how it's working, and we decide what to do. If it is there and if it's opt-in, if it's not usable, if leaking more information, clients can always say no to it. So I think it's fine.
Ian Sweat at Google. So I wanted to reiterate the point about how sending fewer acknowledgements might actually increase the RTT signal and introduce about a 25% noise. Currently, we are running a lot of our clients in QUIC with only sending acknowledgements 4 times per RTT if there's no other data to send. So just like to be aware, there's a fair bit of noise from a technical perspective. If we do this, I personally want this to be good enough that we actually think it's a useful signal. So if we do this, either we need to not do packet number encryption, or I think we probably need like 2 bits, because the last thing I want to do this is add 1 bit and have it be like really noisy. In the cases when the network really degrades, it's complete junk. So I don't want to add this and have it be actively detrimental in obvious ways that we're aware of. So I've spoken with a lot of implementers and a fair number of operators, and people seem to have very mixed opinions in both camps. So I've spoken with, obviously Microsoft said that they would implement it. I can't give you an official answer for Google. I've talked to a bunch of different people, and people have different answers, but I think we're leaning against probably not initially, but maybe we'll run some experiments. But I think we're kind of leaning no. And then on the network operator side, I've talked to a lot of network operators. I was at Nanoc last month, and I talked to a bunch of people there about this. And some people said, that sounds useful, and some people said, I don't know why I would ever use that to monitor and run my network. And so even in that community, I got very disparate responses. I think one of my biggest concerns is even if this is not part of the invariance, if it's in V1, it's going to be an ever-loving pain in the butt to change in the future. And I'm actually as much concerned that this is not enough as it is too much. So my personal preference is that we go along the direction that John was kind of indicating, but I want to be even more specific. I want an experimental draft. I want Brian to use more bits. I want him to try to incorporate loss. And I want, there's like, I think 5 bits available. Use them all. Like, try to get as much information as you can and provide it to the network and try to figure out and run some experiments. What is actually useful? Like, and try to figure out if we don't do this bit or if we don't do that bit, what do we lose? And I guess I feel like this feels a little server pushy to me. This feels like a cool idea that like we think could be useful. And
ooh, sick burn.
And just like server push, we shouldn't have included it in version 1. And I think there's a bunch of stuff we could have done in server push to like experiment with it and make it awesome. And we just didn't do the work before we shipped it to like figure out what we needed to make it awesome. And I think we're still at that stage today where we've almost like over-constrained ourselves down to 1 bit because like no one wants to leak anything. But like it's possible that's just not useful. So like we shouldn't do something that we're not like really sure is useful. So I would rather the endpoints that think this could be useful, Microsoft included, and cloud environments, and the operators that think it's useful, conduct some experiments with an experimental RFC, and we mint an experimental version, and they use all the bits, figure out what they can do with them, and come back, and in version 2, we'll figure out what we want to include in version 2. But I think if we put it in version 1, we're stuck with it forever.
Marcus Ilar, Ericsson. I just want to make some comments on the usefulness and simplicity of this. So we were a bunch of people at the hackathon taking QUIC stacks we haven't looked at before, and we managed to implement a bunch of running versions of the spin-bit. We got them to interoperate. We got really nice measurement results, and we could even do some interesting buffer bloat mitigation techniques using this. So we did see some usefulness already here. And I also think one extremely important thing here is what we call the probabilistic opt-in, because as I think we should do this, and I think we should have probabilistic opt-in, because me as a middle box developer will be forced to do the right thing from the start, right? I will have to take care of the cases where it doesn't flip as expected from the beginning, because this is how the protocol would work. So.
Depends on the amount of traffic.
Manasi Deval, Intel. I think, so I understand this from the point of view of an endpoint, like a client, and I think this looks useful, but this is not the only way to do it. There are other ways to understand the RTT at an endpoint. It also looks like early information, so I would suggest we spend more time understanding it and understanding the value of it before making it a requirement for a draft or RFC. Thanks.
Hi, Eric Sprola. Luckily, I took notes. I guess to sort of echo something Ian said, my understanding from Brian's presentation was that if we do encrypted sequence number, basically we need the VAC, or this basically doesn't work. Is that right, Brian?
Yeah, it's much better. There's a mic in the back if you want to quickly use it.
Yes, if you encrypt the packet number, you get good signal as long as the network is operating well. The signal degrades rapidly when the network starts operating poorly. It's less useful for diagnostics,
right,
unless you have the VAC or something like it.
And presumably the time you want it is when the network is behaving poorly.
Well,
right?
there's two. I mean, there's two. So I mean, there's baselining and then there's diagnostics, and those are two different use cases. But yes.
Okay. So Right. I mean, I think if I have to, if I were given only two choices, you know, the spin bit with clear text packet numbers and the VAC plus spin, you know, the VAC plus spin bit with encrypted packet numbers, I would definitely choose the latter. That seems like clearly like has like superior like, you know, properties. So I guess if I'm not saying there's my only two choices, but were those my only two choices, that's what I think I would pick. You know, I took a little look at where this would actually go if we had the VAC. Maybe I'm missing something, but we're going to do some rejiggering. So we have effectively in the short header, we have 5 fixed bits. The first one's 0, which I think is going to have to stay 0. The second one's the K bit, which we actually need. We have this 110, which I understand some of those things are being used for demux, and maybe we could screw around with some of them, maybe we could screw around with. And then we have 3 type bits, which we don't need them all because we only have like 3 types. So probably we could get away with fewer bits, but we still need at least 2 of those bits, and we could have 1 back. But the bottom line here is that doing the VAC does pretty seriously cut into our sensibility story for like, you know, for like that first byte, right? And so, which isn't to say it's a bad idea, which is to say that like it cuts in pretty seriously, and it makes it pretty hard if, you know, if we discover that, for instance, the, you know, that does not use our space, you know, and we need 4 bits, or we need 2 more bits somewhere else, like for, you know, QUIC version 2, we're like, you know, we're kind of like not in a great situation. So like, if we're going to include, if we're going to include the VAC, like we better be pretty sure that the thing kind of works before we do it, because it's chewing up like a lot of our remaining headroom. So it seems to me that the VAC is kind of like unbaked at this moment. So I personally find it like pretty hard to think about like humming yes or no on like a proposal that includes that, because like if like it turns out it kind of just like sucks, and like, you know, as John and Ian kind of suggest that it might be bad under certain conditions, then we're going to be sad we like use the space for it. But if it's like really good, then we might be happy we use the space for it. And so I understand this feels like kicking the can down the road a little bit, but it's not required for the invariance that we know the answer to this question. And I wonder, is there some way we can get more information about whether like this technique really works? Like before we like make a decision about whether we're going to do it or not. Like I think we have some, like I think one thing we could say is we have like, we understand like the worst case scenario in terms of like the privacy story perhaps reasonably well at this point, and we can decide like, were we willing to accept that privacy loss and the space consuming the header, assuming the technique basically worked really well, and then we can like charter Brian to go off and find out the technique works really well. Like it's not going to take more than like 10 minutes to modify the specification to put this in if we decide it, and it's not in the invariance, so like it's not like it's going to hold up our schedule to like wait till November to decide like if this thing goes in, right? So I'm sorry to be like, hey, kick the can on the road, but I find it very hard to make a decision at this point.
That's a good segue, I think, to.
Can I answer really quickly to one point? Oh, go ahead. AD override, fine.
Okay, well, Brian, I'm going to ask you to answer that.
Okay.
Okay, so Spencer Dawkins, responsible area director, who has been mostly hands-off with the largest group in transport up to this point. But I do want to ask a couple of curious questions. It's different, and I was expecting to ask most of them at the end, but I think this one is probably appropriate. I'm going to ask if you, please hum if you think this is research. Please hum if you think this is engineering. Brian is the chair of the Path-Aware Networking Research Group in the IETF. So I'm going to ask Brian to answer this question no matter how the hum comes out. But
do you want to hum first? Or do you want me to prime the room?
Okay, since you're answering the question in one room or another, decide which room you'd rather answer it in.
I think putting the signal on the packets is engineering. I think the basic measurement that we can do with it is straightforward enough that I would not be able to sell it as research. I think some of the things that we can do with the VAC are research.
I will not ask my snarky question. I will move directly to my serious AD questions.
Before you go on, I'm going to say and I have an answer for you that's slightly different. The choice between whether to let the path do its analysis entirely with implicit signal or to move to explicit signal is architecture.
Okay, we have a lot of
anything else we do here? Is there like a
And
cookies?
Brian is also on the IAB, so there are a number of rooms that this question might be answered in, and that would.
We've tried to answer
Okay.
in all of them
Brian,
simultaneously.
Brian,
Yes,
Brian, I'm going to ask you to return to the queue.
All right.
I think it would do you a service to not have a special place back there.
So.
The only person who can override is our glorious AD.
I wear shirts so people can find me. I'm here for another 48 hours after I walk out of here. Do the right thing. I'm going to try to. Could you hum, if you think you know what's going on here and you think this is engineering? Can you hum if you think you know what's going on here and you think it's research?
Somebody
That
there's
is an
really good at
absolutely
humming.
fascinating hum outcome. Now I will return the room back to your illustrious chairs, who, as I said in the earlier meeting, I picked knowing that there would be days like today.
Thank you very much, Spencer. Someone down here has a real talent for humming. That was projection that was just amazing on that reason.
We got
Give
it
some
back.
classes. Yeah.
And I know who it is. All right.
That was the engineering was quite strong. The research was certainly not trivial, but I think the engineering was stronger. Yes,
So-
but they were both strong.
Not up here. So there's a distinct front of the room, back of the room thing going on in those two hubs. Yeah. Well, right. We've been overridden and we return to the queue.
So, a comment from Jabber from Tom Peterson. I'm in favor of having consensus in allocating n bits for experimentation, like spin, rather than baking spin in.
Martin?
Yes, so I want to look at the broader picture here. QUIC is not the only UDP-based protocol out there, and the only thing that we have in the short header to identify a QUIC packet is a 0 in the first bit. That's all we have. Connection migration and multipath will be a thing with QUIC, or connection migration in version 1, multipath later. So the path will not necessarily see the handshake. So all that a middle box can do is, when it gets a UDP packet, is look at the first bit and say, oh, this is 0, must be QUIC. So this is just wrong. So will the middle box then look on every packet like this and look for the spin bit? And what does that mean for other protocols that also run on UDP?
This is Sanjay Mishra, Verizon. So first of all, I want to applaud Brian for the work that he has done and the hackathon implementation. It's really commendable, I think, the amount of exhaustive work they've done. Insofar as the deployability is concerned, we're already seeing increased traffic on the network, which is a good thing. We're seeing QUIC, but I think some of the things that we are really missing in being able to come here in 3 years down the road and stand on the mic here and say that, you know what, we were glad that we added spin bit because we actually have measured it and we can look at it in the last 3 years and we can say that, yeah, QUIC has done very well and we have numbers to show that. So I think that's kind of where we want to be at. And in order to do that, we really need to start with release 1 now and make sure that spin bit is added. It clearly has the value. And I think we have spent enough time, Brian has spent enough time in trying to lay out the value of it, as well as, I know privacy has been kind of assured, but we can't say 100% that it's all covered. But I think from more or less, we can see that the privacy issue is not as if you look at the benefits and the advantages and the disadvantages, I think the advantage is kind of weighing towards the favor of spin bit. So we really should consider it, and I would really like to see that in release 1, and also look at VAC as a potential for release 2. Thanks.
Mia Kulevin, so yes, this is an experiment. We as a university, we've already tried to look into this as much as we could, but that's a test bed. So we simulated various traffic conditions, which are quite unrealistic today, but might become more realistic in future. Hopefully not, but you never know. And we can say it does work. It gives you the information we're expecting to get it. So that's not a research question for me anymore. The question might be, is this a useful signal? Will people use it? Will people deploy it? But we cannot answer that with our university testbed. You need an operator, you need to deploy it to figure out if it will get deployed. And also Microsoft will not be able to answer this because they don't have a setup where they can actually change both the client and the server. So if Google is willing to deploy it large scale and experiment with it, I'm happy. If not, then we have to bake it into version 1 because that's the only way to get the experiment that we want because we need deployment for it. And I don't really get the point about extensibility. If we figure out it's not useful in version 1, let's rip it out in version 2. That's what we have versioning for. And we can even publish a version 2 where this is the only change. Like, this should be done really quickly. That's the extensibility story we have. So really, we should put it in version 1. The other point I wanted to make is that there's not a limitation from the spin bit on like the egg mechanism or whatever. The dependency we have is that if QUIC is congestion controlled, you need egg feedback. You need at least 1 signal per round trip time, or better like 4, and that's like enough for the spin bit. But this is dependency to congestion control. And I can tell you, QUIC will not go through the ISG if you don't put congestion control in there. So that's the dependency you have, and that will not change.
So we have an hour left, and if everyone in queue takes 4 minutes, we will consume that hour if no one else gets in queue. So please keep your comments brief. And I see the people standing up. We will be closing the queue soon, but not quite yet. Kazuho.
Kazuho, firstly. While I feel sympathy to having this kind of observability, I prefer keeping spin bit outside of the core protocol, because not having the spin bit will help us ship QUIC early. For example, consider the interaction with packet number encryption. And especially because spin bit can be an extension, it is easy to detect whether the client implements spin bit or not by looking at the flowing packets. If you see a square wave, it's participating in the experiment. If you see a white noise, it's not. So it's simply to detect whether if a client implements it or not. So why not make it an extension?
Andrew McGregor, Google. For various reasons, I've been looking a lot at non-parametric estimators of distributions of various quantities. Where this falls in here is that I suspect there's a lot more information you can get out of the VEC about what's happening in the network than is immediately obvious. Some of these estimators are essentially the same computational cost as an EWMA and will track a given percentile of a distribution very, very nicely. The other thing is the same estimators work even if you don't have the spin bit, it's just more expensive. So really what the spin bit gets you is a cheaper way of getting a slightly worse measurement of the RTT than you would otherwise have got by autocorrelating the stream. So the privacy argument is just not there. You can spend the resources, which is not infeasible, and autocorrelate the stream and figure out the RTT anyway. It's just too expensive to do that in a monitoring system for the network. The monitoring system in the network can afford to do the distribution estimators and derive quite a lot of information out of even a single bit spin, but the VEC, it can get a lot. And I suspect a pretty good measure of loss and reordering induced badness.
And what do you think the working group should do? So that maybe this is a question actually for everybody, right? So we're trying to get a sense of the room, and we're going to do maybe Hamza or show of hands later. But if the people in the mic line sort of felt, and I don't want to put you on the spot, right? If you don't want to say that, that's fine too. But sort of, I think that's the question we want to answer today.
Right. And I'll go ahead and put this on screen. This captures what we think the options we've heard so far are. So if you want to speak to these or you want to add to the possibilities, please do. Let's not get too fine-grained. We want to keep this relatively close-grained for the purposes of a decision.
I believe adding anything up to the VEC does no harm. Clear text packet numbers is clearly worse than the VEC.
Hi, I'm Emil from Orange. So we pre-deployed the spin bit on our networks, and one benefit for our customers is that it allowed us to detect bad behavior of the network before the connection fall back to TCP. So, just to say that I support 1 bit for the 0.2 and 2 bit for the 0.1 in the environment. What's that?
No, it's an either or between all four.
Good job.
Ted Hardy, I have a couple of comments, but first a question to the chairs. When do you expect to call consensus on whether we're moving to encrypted sequence numbers? Would you like me to give my comments while you work that out between you? Because
that'd be helpful.
It looks like you might need a little moment here.
We're starting a second stream over here, and this,
Okay.
this stream.
I'll go on to my comments then, and possibly at the end we can return to my question. One thing I just wanted to point out related to the comments that Patrick McManus, everybody remembers Patrick, his comments were some time ago now, about the round-trip time implications. I ran the design team for that, and we could not find privacy implications for them. But I want to be clear that what the design team was asked to do was to look for those implications, not simply to examine whether or not this leaked, because it was an uninteresting question. The answer was yes, that was the intent. If somebody has a different question, for example, whether the VEC leaks more or less than a sequence number, I'd be happy to spin up another design team if the chairs wanted that. I also wanted to note that many people here have offered work to Brian, and I hope you're also offering him money. My personal opinion on what my beloved colleague Ian Sweat said about it going into V1 baffled me, because there's a giant V0 that we've changed enormously, and the idea that anything we put into V1 will be with us for the end of time seems a very, very strange conclusion to draw from that experience. And in fact, I draw the opposite one. I also wanted to go slightly into the question of ossification. I do think there is a risk of ossification here, but I don't think it's the risk people are seeing. I think people are worried that if they put this into V1, it will be hard to rip out, and it will ossify both the expectations of the network operators and the expectations of the stack. I think the bigger risk here is that if we continue to push things into the network without explicit signal as an architectural choice, people will ossify into staying with TCP instead of moving to them when they would otherwise gain benefits from doing so. So that's the point of applause. You people are geekier than I thought. Wow.
They're applauding for TCP.
Oh, wait, they're applauding for TCP, according to Daniel Gunn-Gilmore, who definitely was not applauding for TCP. Let me just do that. And I have stalled enough. Do you guys have an answer to my first question?
Sorry. We're being interrupted, so give us a moment.
We have another sync
so
just came
I'm
in.
going to turn it over to Daniel Kahn-Gilmore to stall for a while.
Hang on, we got an answer for you.
We do have an answer.
So,
sorry.
Yes, one of us needs to stop using the microphone. So
Can you play some music just for a second?
we are about to announce the formation of a design team on the packet number encryption. It took a little while to shake out the participation. I think the email should be coming as soon as one of us has a second to type. So there's people that basically have started to work on this already. We're going to form one of those things that are going to come back with something that looks like a PR.
Okay.
My guess is that we would try to land this PR sooner rather than later, because it obviously infects the invariants, and therefore my guess is that we would do this within the next 4 weeks.
Martin says it doesn't impact the invariants.
Okay, well then Martin's right.
So then my answer to your question here is clearly number 2. It doesn't belong in the invariants of this section, but it does belong in V1. Thanks.
And just to give a little context around that, so far from what I've heard in the room, it seems like there are warm feelings about the VEC. It also seems like people haven't had enough time to look at it, and we need to examine it.
Yes,
so a design team might indeed
if you would
be the
like a
right
design
solution.
team around that, I am happy to spend some energy on that.
Okay, sorry, different design team.
Yeah, VEC, for the VEC.
Yes.
Thank you for offering to do that, Ted. We'll definitely keep that in mind.
Daniel Kahn-Gilmore. I will answer this question. That wasn't what I got in mind for. I prefer to leave out the spin bit for V1, so that means 4, which also means 3. I don't see the difference between 3 and 4 because there's nothing stopping anyone from negotiating extension if we don't put it in V1.
I think the difference, just so maybe others have this missing the distinction, the difference is that option 3 means we would publish an experimental RFC that is, if you wanted to experiment with spinning the bit, here's a good way how you would spin a bit.
So
pick one
this is the right group to produce such an experimental RFC. So sure, yeah, but that means it's not in V1.
And 4 is basically we are not spending cycles on even doing the experimental RFC out of this group. That's the difference between 3 and 4.
Okay. Well, I mean, if it's going to happen, I would prefer it happen in this group because this group has the expertise for it. So,
right.
I actually got in line to respond to a comment from Brian a few years ago at this mic line.
Wow.
Just in particular, he said that he was unconcerned about traffic analysis countermeasures because of the inevitability of traffic analysis on internet traffic. And while I share his fear, I want to encourage people in this room to not share his nihilism. Your comment was a form of traffic analysis nihilism, and I don't think we can afford to do that. Certainly, we don't understand it very well. But Brian, I want many meaty research questions for you to be gainfully employed on for years. And if we give up on traffic analysis now, then that will not be possible. So, yeah.
So I want to inject just really quickly. Not sure what hat I'm wearing, but I've heard in a couple of the recent comments the assertion that if we put it in V1, that, well, if we don't like it or it doesn't turn out well, we can just go and mint a V2. That's very true, except that we have agreed that V1 is primarily about HTTP. So we're going to mint a new version of HTTP that uses QUIC V1. It's not clear if the HTTP community will decide to adopt a V2. That's not a natural transition potentially. Just wanted to highlight that. Brian.
If I may do an AD interrupt just to say something that may be helpful to focus the discussion. Since we just used the words a few years ago at the mic line, it seems reasonable to say that there are a number of possible answers for when the working group might make a decision, and today is part of that possible set. My decision to charter QUIC was made at the same time that we made the decision to not charter Plus. So I made the intentional decision that we would not wander around through that space in the IETF for a while, and it is not okay with me to have the Plus working group as part of the QUIC working group after we decided not to make the Plus working group. That doesn't make sense to me. Now, this is a big room, and almost all of you are non-com eligible, which means you can sign recall petitions, but that's the way I'm seeing it. Doesn't have to be today, but if we're having this conversation after a while, I don't think that's a win.
Thank you, Spencer.
I'm on the mic line. Yeah, hold on. Sorry, conferring with the referees. All right. I missed that point. There was a mention of 2026. First, I'm going to apologize to DKG for encouraging nihilism about traffic analysis for anyone. I just don't have the cycles to work on it. I think other people can. Please don't let me discourage you. I don't have any money to pay you to do the research. Sorry. I'm pretty firmly on 2 here, spin bits and QUIC V1. I heard a lot of people volunteering me to do work. If there is an indication that comes out of this that there is work that will lead to experimentation with this signaling at scale, I am happy to do that work. If it comes down to 3 or 4, I don't know how many cycles I have for that. So just in terms of, people volunteering me to do stuff, just want to let you know. I tend to also agree with Ecker. I'm leaning toward spin plus VAC plus encrypted PN is the right way to go. I mean, I know we're not calling that right now. I think that seems superior to me because there looks like there's information in the signal we can use for other stuff. We haven't done that work yet. Like I said, what can we get out of the VAC? That
There's still some research in there. But the explicitness of this signal, I think, is a gigantic win. So,
Okay.
are the lines closed, or can I run back now?
You can run back one more time, Brian. I'd like folks Brian did something very nice there, which was he expressed what he preferred, but also what he can live with. Oh, look, it's the screen. So if everyone else can do that, we just got a fairly strong direction from our area director that he did not want this to be on our critical path for shipping our deliverables. And he explained why. So especially if you can, talk to, I think probably, option 3 here, option 4, option 1, putting in the invariance is something that is very much on the critical path. So we need to hear why that really needs to be beyond we think it gets it deployed more. So please go ahead.
Ronnie Evan. So my preference is to have it in version 1, and again, it depends also on the encryption of the packet number, what to do with this case, and I think what Brian says was okay. Now, about the usage, there was some comment about network operators, and I can agree that not all it's not all network operators, because when you go to network operators and ask him if they need it, it depends what are they managing. Because if you go to someone who just managed the air interface, he's not interested in TCP at all. Not about this, because his interest is in the lower layer. But if you go to someone who managed the operation of the network and the relation with other network, which he analyzes on the TCP, he has interest in being able to measure RTT and know what's happening on the network. So it depends who you're asking in the network operator. There was
Sorry, excuse me. Can we not have the side conversations in the line, please? Thank you, Ronnie. Go ahead.
Okay, so the other point was about, there was a comment about being able, with this only 0, to figure out if it's QUIC, and I think that's tied also to the issue of the demultiplexing that we had on that, and I think we'll have to consider how to put these bits once, if we put them, in order still to address, because the moment we take all those bits out, the other bits out, then we need to look at what are the right, how to build the first byte anyhow. If we want to support the demultiplexing document that's also in AVT. The last point is about, I forgot the last point. Okay, sorry.
No, thank you, Ronnie. The queue will be closing in 30 seconds. Go.
Hi, Al Morton. 30 seconds, wow. Let the race begin. I'm always short at the mic. To Ronnie's point, basically to Ian and others, yeah, I experienced the same thing. You go to NANOG, you'll talk to a lot of guys who are peering experts and BGP experts. They won't really care about troubleshooting user flows. That's important. When it comes to the patterns changing, like the unreliable streams, the ACK reduction, all the things that can change, that's kind of like just describing the day in the life of passive measurement designers. If it changes, we have to change it tomorrow. So I think that's the role that we're in, following what others do. We have to make the measurements work if they're going to work. For all who want more study, Brian's slides did not cover the entire draft. Please read the memo. One of the things that was studied in there is one of the things that Andrew brought up, this autocorrelation, where you can just look at inter-packet times and try to tell what the round-trip time is from that. Andrew, it's really hard to make that work. And the draft points to a reference for that. It's probably even harder to make it work with QUIC, where we don't understand right now what the inter-packet dynamics are going to be. So let's not, this is the alternative where we don't get a spin bit. If we just look at blind packets, can we measure anything? Probably not. But that's research, not engineering. Oh yeah, so my choice would be number 2, QUIC and V1. I can live with encrypted packet numbers and the VAC. Thank you.
Thank you. If you have the preference for QUIC V1, I would really like to hear why it needs to be V1 rather than a negotiated extension. If you want to speak to that very briefly, please do.
let's get the large-scale experiments going that people would like to see.
Sure.
Thanks.
But that presumes that people will actually deploy it in V1, so.
Yes.
Okay, so the queue is closed, back there at Brad, got in just under the wire. The folks in the queue, 1, 2, 3, 4, 6, 5. Yeah, you've got 2 minutes each and absolutely no more. I will be timing, go.
Martin Thompson, Ian's comment, I think, resonated with me quite a bit. We've been sold a lemon before, and in this case we don't really know what the shape of the right lemon is, so I have a slight preference for 3.
Thank you.
Giuseppe Fioccola, Telecom Italia. I will support the additional spin bit in V1. This can allow a network operator to measure not only the end-to-end round trip, but also by using the RFC 8321, also the performance measurement of its own portion of the network of the complete RTT. So this can be useful for 2 aspects.
Thank you. We're doing really well.
Praveen, I wanted to clarify a question, a comment that Media made. We do run some large online services and we will be able to do such experiments at scale. The other thing I want to point out is that the primary use case was the cloud where, we could run QUIC in the data center for other use cases other than HTTP because it's a general purpose transport. So it's certainly useful from that point of view as well. And we can do those measurements. In terms of preference out of these options, 2 is the preferred, but we could live with 3.
Thank you.
Subodh Iyer. I think the option 1 and 2 are facetious because they're actually joined together. The version is not in the short header, and the experiment that Brian was running uses the IP address as the key. It is very, very possible that we're going to run multiple versions even before we deploy an RFC version of QUIC as draft versions. The second point is that I don't know how it could be option 3 either, because to have a supported extension, the middle box would need to be able to peek into the initial packets and maintain more state per connection. That would also infringe upon so it must maintain a map per connection ID, and that might affect the design decisions in maybe changing connection ID each and every round trip time if a server and a client wanted to do that as a privacy preserving method. I have other points as well, but I'm going to make it brief. I'm concerned about the differential behavior based on spin bit that might be offered by network operators. I'm not sure what the implications of that are. Network operators have done things like deploy TCP middle box proxies before, which have kind of sped up TCP. I don't understand that well enough, and I don't think that's covered well enough in the draft. And I don't think this meets the engineering bar either of including in V1 right now. This was tested, for example, limited situations like flow control is disabled, congestion control is disabled. I would like to see it kind of tested in real world traffic environments like HTTP, realistic HTTP flows with multiple concurrent requests with HTTP2 transports before it actually can be included in V1. So I don't think either of these options are actually like real options.
It's about, before you go, just a clarifying question. If the extension was not negotiated, it was just, each side opted into using it with an extension in the extension framework, would that address your concern?
I don't think that extension framework exists right now in our packet format, so we would have to design that extension format just for this particular spin bit, which might push us back along. And so I think this has privacy implications, not because of the fact that, hey, it's exposing RTT, but it prevents us from doing all these other things in QUIC based on the fact that we middle boxes want to be simple and use an IP address, a 5-tuple as a mapping proposal, whereas we're considering connections as not 5 tuples, and there's a mismatch between the endpoints, what the endpoints consider as a connection identifier, and what a middle box considers a connection identifier. So it is not possible to remove this out because short headers are supposed to be small and they're supposed to be efficient, and so they will never include the version. So there could be multiple versions on one 5-tuple, and I think and there could be multiple connection IDs on one 5-tuple as well. So 5-tuple does not make sense to me.
Okay, thank you. Jonna, I see you back in the queue. When you get to the front, can you put your editor hat on and speak to how this would integrate as an extension? I'd be interested to hear your perspective, and you'll get extra time, don't worry. Please go.
Eric Nygren, Akamai. I think
actually following on to something Simone said at the end, I think it's worth thinking about adversarial and kind of what some of the consequences could be. And I'm curious what vendors are thinking about in terms of when they might start looking at using this for controlling flows and trying to optimize flows rather than just using it for passive diagnostics. Because I think the risk there has a significant ossification risk that could turn this, putting this into V1 from being something that's kind of a research experimental, what happens with it, into something that really becomes an engineering question. And that kind of pushes me along with Ian's perspective towards thinking we should really experiment more and figure out exactly what we want. And therefore, I think I'm leaning really strongly towards option 3, even if we don't know how to do the extension part yet.
Thank you. Next.
Eric Scorla. First, I'd say Christian sent an email that lists his opinion, which appears to be that we should reserve the bits in the spec. First, let me say, like, the cost here primarily is, I guess, 3 things. The bits, having to rearrange the bits a little bit to make room for this. The cost of, like, doing anything. The editorial and working group work to, like, actually do the specification, and of course, the potential privacy loss if it's a problem. Second thing I would say is, like, this entire project is like at some level an experiment. What I mean by that is, like, you know, we're designing this protocol, and then we're going to field pieces of it, and we're going to see if they work properly, and, like, if things don't work properly, then we're going to take them out. So, like, and that can still happen between now and V1. So I don't, like, actually, like, I feel like a little bit like the, you know, like, we don't know if this works. Like, if our objection is we don't know if this works, the way to, what we think it would be a good idea if it did work, then the way to deal with that is to, like, actually just, like, put in the protocol and let people deploy it and see if it worked or not. So I mean, like, you know, otherwise you're never gonna know if it works. So I guess it seems like if the objection is like a bad idea in principle, that's one thing. If the objection is we don't know if it works, we should, like, do the thing we're doing everywhere else. I guess one thing I hope Brian will say when he gets up, because I'm actually not particularly clear on this point, is I'd understood that basically if clients didn't participate, that Brian's measurement framework was able to process that fact properly and was able to ignore the clients that weren't participating. And if that's true, I don't see why we need a negotiated extension. Clients either do it or they don't do it, and servers either do it or they don't do it, and, like, Brian's measurement framework figures that out. If that's not true, I'd like to understand that point. But if it is true, then these questions of negotiated extensions are irrelevant, and the only question is, do we define the do we make room for the bits and have somewhere to find the semantics of them?
Mike Bishop, Akamai. I'm actually here to make 2 observations about the short header and the first byte. First off, the signal that it's QUIC actually is not just that it starts with a 0. You have 0 something 110 as currently defined in V1. So the signal that it's QUIC V1 is 4 bits out of the first byte. Of those remaining... Okay, so we will get rid of some of those or be able to assign them other uses. Then we have the 3 bits of the type field. Currently, the only thing we communicate with type is the length of the packet number. And as part of the existing packet number encryption proposal, we're going to move to varint for that anyway. So we're not doing anything with those type bits. I'm kind of leaning toward 3A, that we block those bits off as reserved, and let's do an experimental RFC. If people want to play with it, fine. And we'll figure out if it's something we want to bake into V2 in the future.
So to be cool, when you say block off, you don't mean put them in the invariants, you mean just have them undefined in V1? Correct. Thank you.
And I think it would be a very bad idea to put them in the invariants.
Dan Drutz, AT&T. It's been a long exercise, but I think there are a couple of things that I wanted to say. One is related to architectural principles, that this discussion took the right direction, basically, with the opt-in and with the explicit signaling, and I think it's the right way to avoid guessing in future protocols. And the second one is more process between the experimentation and the ability to do the privacy analysis. I think these were 2 things that kind of gave the proof that that this thing makes sense. So I personally think that we should opt for spin bit in V2. we should put it in in V1. I'm sorry, in V1 with even if at the risk that we may do a little bit of a privacy analysis for an extra bit or so. I think it really needs to be in V1. So thank you.
Jana Iyengar. I'll quickly state what I was going to come up and say was my opinion, which was going to be number 3 at best, not 4. But not 2 or 1, because I think 2 and 1 both put the spin bit on the critical path. And now with the editor hat on, I'll say that that's actually a real issue. We are still trying to shoot for November, and it's becoming increasingly clear to me as we go through this conversation that there are corner cases here, and there are edge situations that as we start writing this up, the issues list is going to explode again, and I'm terrified of that. We just spent a whole week trying to really trim it down and really get it under control, and if you have to repeat the exercise again and again, that's not going to be a lot of fun. Well, it's going to happen anyways, but I'd like to not add more fuel to that explicitly. You asked about the negotiated extension.
The timer is now off. Go.
Sorry?
I turned the timer off.
Thank you.
Yeah.
We don't have a well-specified mechanism yet. We agreed in Melbourne in the room that something like that would be useful to have, but we don't yet know if it's going to be. I don't know yet if it's going to be encrypted or not. We haven't decided on that. We haven't agreed on that. We don't know if that's going to be encrypted in subsequent versions of QUIC or not. Any design that we put in here will have implications on what we end up doing. So again, if we go to number 3, I'm starting to get concerned that we end up poking other things that we want to do, and it's going to delay all that other work as well that we need to do. It's going to have implications for sure.
And can you speak to the idea from an editorial perspective of reserving the bits for future experimentation? Is that feasible?
I think we can reserve the bits. I don't think that editorially there's any issue doing that.
So we'd reserve them, increase them?
Reserve them, increase them.
Okay, it sounds like Brian wants to address that, so let's keep on moving.
So yeah, to Ecker's point, yes, if the one endpoint opts out, it's extremely easy to see that happened on the past, so there's no point to put this in a negotiated extension. It's just, yeah, it's on or it's off, right? If we're looking at going to variant packet numbers or variant encrypted packet numbers, we have these bits in type that V1 will not use for anything anyway, and we will have to grease them, and if you want to grease them, you can spin them to grease them, right? You can probabilistic. This is useful grease, right? This is one way to look at this. With respect to, I'll read. Is there a clarification question from the chair?
As an individual, I disagree that spinning is greasing, but keep going.
Okay, yeah, right. Right. So we can have that discussion over a beer. I continue to believe that 2 is the right choice here. Again, spin bit, VEC, encrypted packet number. With respect to, 3 would be an extension that's not a negotiated extension. What I would want to see with 3A is for the core spec to essentially refer to the experimental document non-normatively to say this is the experiment that we're using this for in V1, if we do an experimental document with reserved bits. Otherwise, there's no reference to it, and basically the people who are going to know what's going on about that are the people in this room. The other thing that I would like is through a wiki or some other thing, or maybe on the list, is to get a feeling of how many people would participate in the experiment in 3, because I don't need an experimental extension to do it myself. I do it myself right now just by hacking people's implementations, right? So
Brian, you're off the clock.
Yes.
I keep on hearing people say we should put it in QUIC V1, and my impression is that they think that by doing so, they'll get deployment of the spin bit. And I don't know that that's the case. So can you speak to why it's important?
Yeah, I am not stating that putting it in QUIC V1 is guaranteeing deployment. I think that putting it in an experimental extension guarantees less deployment than putting it in QUIC V1.
I think we should, well, once the queue drains, we'll maybe have a discussion with implementers.
But that is my, it's not, deployment guaranteed, that's that these two are in an order,
Right.
and I believe one of them has less deployment.
Right. So,
And-
chair hat on, so far I've heard a number of people say I prefer QUIC v1, but I haven't heard a structured argument as to why. I have heard a lot of people also say I don't want it to put it in v1, and the arguments seem to be more structured for not putting it in there. So if we can explore that relationship, that would be really helpful to help us make a decision.
Okay, that's my answer, right?
Okay.
So, yeah.
Thank you. That's helpful.
Just let me add on to that one. So one thing is more deployment in the endpoints, but the other thing is also what Sabut says, like you also need a way to actually know where the bits are and read them. Otherwise, the experiment is useless. Given we don't even know how the extendability framework would look like, I don't think that is actually an option. It's not an option I understand, at least. I also don't really understand the difference between 3A and version 1, because if you reserve the bit and then you have another RC that defines the bits, I don't think that just writing the word experimental on top of the RC actually changes a lot for other people. And even if you put it in V1, we all know you can still set them to 0, so that's the same as they would be reserved. What I was hoping out of V1 really is that the RC would say the server side should or must support the spin bit, so you give the decision to the client.
Chris Seal, Hutchison. My preference, I'm an operator. Yep. The preference is option 2, but the main reason is I wanted, just like Brian said, I want a reasonable sample size, and if it goes too experimental, I think there won't be enough. And the reason we actually do this now with TCP ACKs, and we use it for early detection of congestion, and that in turn then feeds upgrading the network. So I suppose the point is if you make us blind, then we either have to, it's a sort of just-in-time, efficient, cost-effective management of a network is about just-in-time upgrades and things. If we don't know that we need to upgrade until it's too late, it's a bad customer experience. If we upgrade way too early, then we've deployed CapEx when we don't need to. Thank you.
Thank you.
Jörg Ott, I want to come back to this point that was just made about what we can gain from TCP sequence numbers and so on. It occurs to me that if you look at a flow of TCP sequence numbers and ACKs, you are inferring a signal directly from stuff that's happening that is making up the actual data exchange. Whereas the spin bit is an independent signal, irrespective of your other connection progress. So you can tweak that way more independently. At least it seems so. And so it looks like we are all assuming well-behaved clients that don't try to game whatever the operator does. So right now we have been thinking about people looking at, we are going to do measurements, but probably you're not just going to do measurements and say, we have this RTT, but you're also going to have certain assumptions or maybe reactions. So I'm wondering whether we could take some time to investigate what an individual flow can do by lengthening your period, which is easy to do. Maybe shortening this to shortening the expected RTT is more difficult to do. But if you have one or more, one client, one connection, a set of colluding ones, how they can actually manipulate or drive network behavior. I don't think this has been investigated. And so we are just making too many positive assumptions at this point. So this is why I would probably, from my side, even though I don't have a strong feeling and I don't have any bets in here, I probably go for option number 3. For 3A, the main question is if you reserve bits now and you need one of them later, how many bits would you want to reserve and would you take this back? So I'm not sure that reserving the bits as of 3A is necessarily future-proof.
Okay, thank you, Jörg. I just wanted to mention when we set up this conversation a few months ago, that was one of the items that we called out explicitly was, how can this signal be gamed? What are the systemic effects? And we didn't really see any response to that. So I share your frustration that wasn't explored. Sorry? You have a slide. Of course you do. Oh, well, maybe in a little while. Okay, thank you. Go ahead, Ian.
Ian Sweat, Google. I wanted to comment on the negotiate extension and the exact approach that I am proposing we use. We have a way to change QUIC. It's called version negotiation. This is an excellent opportunity to use it right out of the box, opposed to waiting and trying to mint V2 and realizing it doesn't actually work. So I actually think this is an excellent test that our version negotiation is actually functional. And so I'm specifically saying we should define a 4-byte QUIC version that is run concurrently with QUIC v1. And if you say that you are using that version, which is in the clear and like very easy to look at, assuming you actually do get to see the handshake from a middle box perspective, then that means you are using the spin bet and or bits and defines how you are using them very clearly. So there's none of this like, we might be greasing it, we might not be BS. It's just like, these 4 bytes mean like, we're using the spin bits and this is how. And that's kind of like what I have in mind in what I, well, none of these things work with connection. Okay, well, I mean, it doesn't work any better or worse with connection migration.
Is this effectively what you're proposing, 3B?
Sorry.
3B?
I'm saying that's my embodiment of how I think 3 should work.
Okay.
That's what I intended 3 to be. So
yeah.
I just want to mint a version and say like, it means, so the nice part about this is like from the version you can tell. Yeah, I mean, in many ways you can say it's like very, very similar to the QUIC v1 option, but now I have a version that defines how I'm using the bits, which means it actually exercises the version negotiation capability, and I think it's, sure. What?
Ted?
Ted Hardy, I have a clarifying question. You said earlier that if HTTP was defining a version to run over QUIC, would in a case like this, it be defined to run over all versions of QUIC of this type? Because that makes a serious difference on the points the operators have made about the sample size that's necessary for this to be useful for them to do their work.
Sorry. Oh, anyway.
Understood.
Mike Bishop, editor hat on. I think what it currently says is that
We're low on time. Okay. Sorry, go ahead, Mike.
I think what it currently says is that it uses a version of QUIC with TLS as the handshake protocol. So that is a set of QUIC versions that would be supported by the HTTP draft.
I want to make one editor clarifying comment that if we do this and we make it as part of QUIC v1, I would prefer the reserve the bits in the transport doc and actually have a separate doc for this.
Brad Lassie, Google. I got up to say effectively what Mark said. I don't think there's much of a difference between putting in V1 and not, and making it experimental in terms of how much deployment we'll get. I don't think it being in V1 will influence our decision to include it. So my preference is for 3A or 3B or something around 3. I also just want to make one other point. Is one of my big concerns is when we get beyond measurement and try to actively manage based on this, and how that will mess with flows that aren't standard, send and receive ACK flows. Thanks.
You can very briefly.
I would like to reiterate the observation during the talk that these bits are, as are all header bits, integrity protected. So a lot of the fear that we have about the meddling that happens in TCP, we've already built a way to make that not happen. So the space of things that you can do is way smaller.
Right. So we have 20 minutes left. Spencer's reserved a block of time at the end. I think for me personally, the Miria's comments combined with Ian's were quite illuminating. And the way I'm thinking about this, and I'm happy to have this shouted down, is that it's either we would put spin bits in QUIC v1 now, see how that experiment goes, and with the understanding that it is an experiment, they might get pulled out before the end of QUIC v1, before it's shipped. But the more viable solution, I think, is along the line of what Ian was talking about, where there are 2 QUIC versions, one with spin and one without, and we see how that goes. Because potentially that means that the one with spin bit is not on the critical path for the one without spin bit, which I know makes our AD a little bit happier. So how do people feel about that? What I think Ian has roughly proposed very specifically.
Mia Kulevin. So the difference is that using the version number, you actually also give assuming version 1 would be the server has to support it, then using the version number means the server can veto and say, I want to use the non-spin bit version. But that also might cost you round trip time, right?
Okay, I want to just interject one thing there. In all of our discussions so far, we have not talked about mandatory support. The assumption has always been that it's opt-in on both sides. So I'm just as a chair, I'm scared that this is going to knock us back several steps in consensus.
So I think the difference between those proposals is really just the tiny little details. There is no big difference.
There's one other difference.
Okay.
First of all, there's actually an observation here to this whole thing. I think it's cute that we are pretending that QUIC v1 itself is not a gigantic experiment. Oh, sorry. Oh, yeah. Oh, sorry. I got to get out of Ecker's head. I really like Ian's, the more I think about it, the more I like Ian's proposal, separate QUIC version with spin bits, because one of the things that scares me about QUIC v1 is that we are going to have a lot of version negotiation experience with the implementations that we've done here, because we're doing version negotiation as part of our interrupt testing, and there's not going to be a lot of exercise of the version negotiation mechanism in the wild. So having two, I've been saying for a while, we need to have two separate versions. I thought those were QUIC v1 and QUIC v2, but maybe they're QUIC v1 and QUIC v1 spin, right? So we get to kill two birds with one stone here, and that seems efficient to me. There was another question. Yeah, Ian, go Ian.
Okay. I think one of the things that Laura's mentioned on the side that we should at least consider is that does this set up a marketplace where a network operator could decide, I'm going to block any QUIC that doesn't allow spin? And what are
Any
the
network
effects of that?
operator who is deploying boxes that will let through QUIC v1 spin and not QUIC v1, who actually wants the visibility that you get by looking at TCP and isn't just blocking QUIC to go to TCP, is not doing the right thing for their goals, right? I think the risk of blocking QUIC v1 in favor of QUIC v1 spin is so much less than the risk of just saying, fuck it, we're going to block and go with TCP, that it's not.
Sure.
Yeah, it's the right thing to do.
Okay. We need to get some hums and some AD comments. We need to keep all of these comments very brief, and I'm going to cut the queue. Go.
Janai, a very quick question to the chairs. We can separate out this QUIC version. Does that mean we change our goals at the moment of what we are doing in terms of driving towards V1 by November? Because
No.
V1 is version 1.
Yes. This will be a second
This would
version.
be a separate version, yes?
And it would, I
Experimental or
think, be
whatever.
a separate document.
Yes.
I
it will
would
be a-
hope so,
yes.
and my hope is that this is after V1, not along with. After.
If it
but
can be
close in time.
parallelized, that's, yeah.
As long as that's, I want to make sure that we are in agreement, or at least we talk about that very quickly, because
Sure.
it's going to cause, again, us to have to do work otherwise.
So it must be, it can't be before, right? Because it requires V1 to be done. But V1 needs to basically be done, and then, because this is going to be a diff that says, you take V1, this is the new version, and then you spin stuff. So therefore, it's in hand or after.
So I guess I'm still a little confused about what's being discussed, frankly, amazingly enough. If it's in, so we've already agreed that that if it were to be in V1, it would be optional to actually execute. And so if it were in V1, then you would only have no wire signal, and you either send spin bits or you would not send spin bits. And so there's a question about whether you wish to have an explicit network signal about whether you're sending spin bits or not. And if you do, then we should have one. If you don't, then we shouldn't have one. If we don't need one, then there's no point in putting it there's no point in having a separate version. If we do need one, I'll argue in a second that a separate version is stupid. But to make that separate version, to make the separate version thing be plausible, we have to make sure that we really room in the header to flip those bits, and we're not screwing around with those bits. We haven't colonized those bits in V1. And so I just don't see much material difference between the work the worker will have to do in the case where it goes in V1 and the case where there's a separate version, if no one gives a shit about in-path signaling at all, because specifying the use of the bits is not difficult. Separately, if we do think it's important to have explicit indications on the wire, Like, please, let's not do a separate version. Like, the idea we have to have like orthogonal, like we have to, like a combinatorial explosion of versions every time you introduce a feature, like is like a trivial feature is just crazy. That's why we're doing an extension negotiation mechanism in the first place. This is a classic use of why you want extension negotiation. If we want to have like, if we want to exercise the version negotiation function, let us define QUIC1 and QUIC-V -1.
Okay. 1 minute each.
Ronnie, first of all, 3B is still experimental. I was not sure I understand that, because is it a regular version, standard, be a different transport version, or is it be an experimental RFC? Why is it 3B and not a separate item in there?
That's just to preserve the numbering so people don't get confused.
Okay. Now, so from my point of view, 2 and 3B are okay. The reason for 3, the experimental, I think that we're talking here about the transport, but this transport is typically some other standard body are defining what transport are used in a network. And they will reference such documents. And they can reference a document that will have without SpinBit or with SpinBit, but they'll need the document to reference for that. And I assume that in 3B, we means that they will progress in parallel and not sequentially.
Thank you.
Subalanger. So I think that 3B is, there are a lot of dragons lurking in there, which like it seems quite simple as it's described, but it's actually like probably way more complicated. It's not as simple as the mechanism Brian described in his draft of like, just look at the 5-tuple and you're done. You have to maintain a lot more state for that. So like before anything, you need to see what the solution is and iron out all the dragons. And I think that anything that we do, even for a separate version, I think if a middle box is going to look at it, it will practically have to be an invariant. And since it has to be an invariant, I'm kind of opposed to the idea of putting an experimental thing inside an invariant. And so this is like a circular argument here, but I think that as has proved, like this cannot be a separate version, and this cannot be an invariant either. So we need to come up with a separate version negotiation mechanism, and we need to put in the work to do that if we want to propose this, and this might push back other work in the long header format.
Exactly 1 minute. Congratulations.
Ian Sweat, Google. I wanted to address Mary's comment about the extra round trip. I was going to say that in practice, I expect most experiments, at least initially, to use the out-service advertisement mechanism, and so the peer would just learn about it via HTTP and then like do it the first time. Basically, we just not do it once. So I don't think there'd be actually any practical hit on user experience. And then on the idea of negotiating extensions, the extension negotiation mechanism that I have in mind is encrypted, because most of the extensions I want to do I want to be entirely encrypted, and so I don't really want to use that extension negotiation mechanism to negotiate something that is outside the encrypted envelope. That seems weird to me. So, I mean, we could do that, but the point here is to like actually give the path information. So why are we trying to do that negotiation in an encrypted way when the whole point is to give the path information?
Thank you.
So Emil from Orange. So I support the option 2 because it will ease the works with regard to participate to the interrupt day and so on. Because currently we have a separated code for the spin bit, and so it's very tricky to make interrupt test. This is a result of the hackathon here. We have separate table, and so we were trying to put the spin bit in older version, and at the same time the developer were implementing a new version on the QUIC table, so it's a waste of time to have separate code.
Thank you.
Sanjay Mishra, Verizon. So Mark, going back to your question about earlier, you asked that you had not heard as much about the structure around why you need in V1. So I think really the question is that the deployability and manageability, they kind of go hand in hand. So if you're looking to standardize QUIC and deploy it in the network that allows operators to maintain the same level of service as they do today, you really need to consider the manageability aspect as we deploy QUIC. So if that goes with V1, then we stick with V1. And I'm not really sure if having a 3B option really helps. So I think I would stick with where we are. And as Brian earlier said, that the implementation itself was not a really big sort of adding to the structure of how long it'll take to add this thing. So we should be able to add this into the current release. I'm not really sure about the 3B. And unfortunately, I'm seeing a big divide here between those that are designing QUIC and those actually would be managing and running the network. So this divide has actually increased much more before the call started and where we are right now.
Okay.
It's unfortunate.
Thank you. So we're going to take a slightly different tack. Can we see a show of hands in the room of who is implementing QUIC now? Okay, keep them up. If the spin bit were to magically appear in our specification tomorrow, would your implementation be emitting and honoring that part of the specification? If it would, please keep your hand up. If it would not, please take your hand down. Okay. So there's some wavy hands that aren't sure. Good. There's a hand back there, and there's a hand here, which are the same hand, kind of. You two are sharing a hand in that sense, right? And there's kind of a wavy hand here. So 3 wavy hands and 1 combined yes or implementation, and 1 over here. Okay. Oh, that's a wavy hand too. And okay. We tried to filter that out. I think we mostly filtered that out. So there's some interest from implementers in at least experimenting with this. We had a back and forth about, how we would do this as an extension. It sounds like there are more questions that brings up where we're not really sure that that's a viable path forward. So I don't really think we can make a conclusive choice about that now. If we were to land, Brian, is your pull request still clean? I believe so. Okay. All right. So one thing we could do is land your PR and have some experimentation, see how many people actually emit and work with it in the next few months, and make that part of the implementation draft goals, and then evaluate that later on and make a decision about whether it remains in the draft. And I want feedback to that approach now.
I would, that seems like a good approach going forward. Hi, Brian Trammell. That seems like a good approach going forward. One other thing that I heard in the room is that there is, tied to the emerging consensus around encrypting the packet number, there seems to be a lot of support for VEC, and I would volunteer to do another PR to add the VEC when the encrypted packet number lands.
For purposes of sanity, I consider VEC a separate discussion.
Yeah, okay, that's fine. Yeah, I'm happy to clean up and land the 1-bit spin.
I'm trusting the people in line to be as brief as they possibly can.
Suggested addition to your poll of who, the implementers if it wasn't in V1 and just experimental.
Sorry?
Rerun the poll
if we did
we would implement
in the future.
If it wasn't in V1.
Okay, so same question. If you're an implementer and we did it sometime in the future, would you emit these bits? I see wavy hands from the Google guys at front, and a wavy hand from Akamai still, and still a strong hand from Microsoft, and a wavy hand. So the same set of hands. I don't think that moves the needle. Please go quickly.
Ronnie Evan, I think that the problem is that the ones who wants it are not the ones that are implemented the client side. They are the ones that runs in the network, and eventually they will ask for that either by specifically asking or by blocking. I mean, that's what will happen. So you can say you don't want to implement it. It doesn't mean much. It depends what will happen actually in the networks once it started to be more deployed.
Jana Iyengar, editor hat on, this will make life very difficult. Not just in terms of managing the text, but in terms of mechanisms. I'm really hoping that after the IETF we start, getting into the packet number encryption issue and try to land a solution to that. This just sort of stalls everything up until we can resolve it.
But we're talking about resolving it today.
No,
effectively.
Once the PR is landed, the document has to be self-consistent, yes?
Yes.
And we have to figure out how to make sure that everything else that lands after this is going to be handling spinbit.
Okay. As a chair, I have every sympathy, and I want to do everything I can to support you as editors, but we cannot make editorial convenience a gating factor for the decisions we make. I'm sorry. Martin.
Yeah, Martin Thompson. Despite what you just said, I agree with Jana on this one. We're talking about polls. This one would be another one in the tent. It's not a long one, I agree, but it's just another one. We've got a lot of work to do.
I understand.
Anyway. Yeah. And I don't see any problem with a separate document, frankly.
If I could make a statement really quick, just to inform, so that everyone knows what the chairs know. I asked for 3 minutes if the hums were not going well, and 1 minute if they were. I believe we have 5 minutes, and we haven't taken these hums. Do the right thing.
You didn't say how many minutes you want to.
Ted Hardy, I thought your poll had interesting results. I would be also interested to hear the results of you asking the people in the room who run networks how many would use the signal to measure RTT if it were available.
That's a good question. Who in the room runs a network? Try to deduplicate yourselves if you can. Okay, and put your hand down if you would not use this to manage your network in some fashion. Okay, a couple of hands go down, most of them stay up. Okay, Lars.
Lars Eggert from the floor, and not as chair, but sort of what you proposed, or I think what I heard you propose, actually changes how we work, right? We don't land PRs and then unland them. We try hard to get consensus for the PRs, and once we have consensus, we land them in, just because what Martin and Jana said, right? It becomes really difficult to do the unlanding. So I object that we change the process that we have in the working group that's worked quite well in the past, just because this is a hard topic.
So one thing we could do is, to address that, one thing we could do is leave a couple of, a combination approach, I suppose. We could reserve a few bits, have a separate document that describes how to use those bits, and if at the end of our process we agree that this is indeed useful and is actually getting implementer take-up, we can incorporate that into the spec before it ships as V1.
Marcus Sealer, I just want to say that I'm not implementing endpoints, but I'm implementing measurement devices that use this, and I would be happy to contribute to any work that needs to be done now in the short term to get this moving.
Okay. So the most recent, Jana, you went on? Very quickly, though.
Very, very quickly. This just changed the equation, though, in my mind, because I think this means that we are going to actually discuss spin bit issues now, between now and November, quite a bit. I just want to make everybody in the room aware of that fact, that we're going to have to not just identify issues with this particular proposal, we're going to have to try to solve them.
Right. So I think the two, as I understand it, the two possible paths forward are to defer putting the spin bit in V1, or to reserve a few bits, have a separate document with the idea that if we prove it as a viable thing that gets implementation support, and we'll probably have to have a rough consensus further down the path, we'll fold that separate document into QUIC V1. Does that sound like the two options we have? I'm looking at you, Lars.
Yeah, I know. I'm trying to not look back. No. So those are certainly options. So I'm not. So I'm not any. So I'm not any clearer, really, unfortunately, than when we started this morning, right? So it's.
Welcome to the
I was sort of
IETF.
hoping that we were concluding on this today, and it's very clear that we're not going to conclude on this today. It seems like, and therefore, so I don't know if Spencer, who wanted some time, has questions in his mind that would help him.
Are you
forward.
kidding?
They might help me too.
Okay.
Okay. Sorry.
So
Yes,
I
that is a-
think I have 1 minute, so that means the hums must have gone well enough. I want to say a couple of things. This is a way, I think this is the most positive conversation on this topic that I have seen since the RFC on pervasive encryption being an attack was published. I would like to thank the working group for that, and I would like to thank the chairs especially for that, because even though all the transport working group chairs take a lot of crap, these guys managed to still stand out. So I would like to thank you all for that. I want to say one other thing. So I got the you're not have a real fuzzy feeling about the direction yet. Do you two have a real fuzzy feeling about the ability to close on this by the interim? Let's say on the mailing list.
Having had some water, so I would summarize this meeting today as sort of it's very clear that there's enough interest from a variety of people to use the spin bit and understand what it's good for and learn more about it, that I think sort of the option 4, right, no spin bit ever, I think, rather than no spin bit V1, I think that is out. I also think the option 1, spin bit in invariance, is sort of out, right? So that's nice.
I would agree with those. Yeah.
If we hadn't added 3 other options, that would make me very happy.
Well,
but sort of, I think there's sort of...
I really think we're down to this.
I think, so we're looking at an approach to manage, give people the ability to experiment with spinning some bits in QUIC as it gets shipped without delaying the rollout of QUIC V1. And I think we're sort of trying to find an approach in an ad hoc manner here, and I'm at least not coherent enough this morning to propose one. There are 2 here that you have proposed. If people think those are concrete enough ways forward that we should have a hum or some show of hands or something on them, we can totally do that.
Is that A or B or A and B?
A or B or C.
A or B or C. Okay.
Yeah. Okay. Let's hum these out, and then I think we're going to have to huddle, hum it out. And then we're going to have to talk to our AD and see where we go from here. Clarifying questions very, very, very quickly.
Yeah, I don't understand option A.
Option A is that we will not put a spin bit in version 1 of QUIC.
Where else would you put it?
Maybe in a future version, but that's a separate working group or a separate consensus. It's not now.
Martin Thompson, can you clarify the difference between A and B in terms of what it is this working group will do between now and the end of the year?
That's a great question. So if we choose A, this working group will not talk about spin bits in our current scope of discussion because we're talking about V1 right now. If we choose B, we'll instruct the editors to reserve some bits. I think Brian will, if he's willing, spin up a separate document. We will talk to implementers and put the use of that document on the implementation drafts as a goal. Not a required goal, obviously, but we'll try and encourage the implementers to experiment with it. And we will, at some time later this year, revisit this whole, well, I say later this year, assuming we do everything else on time, we will revisit this issue and we'll have this whole conversation again about incorporating that document based on that experience we had.
Okay, but that's after the shipping. Is the expectation that we would adopt a draft based on this? So we would see a draft in some number of weeks and then we would talk about adopting it?
We would adopt a draft, but not have a milestone for that draft yet. Yeah, we do not have time for a queue, I'm sorry. Miria, as an AD, do you want to speak?
Very quick clarification.
I'm still confused about, so I think B is independent from the question if it's a separate document or whatever. It's like, we will try to do some experimentation now and revisit the thing before. So
B is how do we do that in experimentation?
So I think the difference is with A, the working group agrees to not devote time to the spin bit in the time period that we're spending on V1.
It will not be discussed.
We will discuss this as part of the working group, and we will try and enable people to experiment and report their results in the working group.
I have a clarifying question as an editor.
Very quickly.
For B, does this mean that as we are working on other mechanisms, we must consider the spin bit as we are writing them down in the document?
No, that's what the other document is for.
Sorry?
That is what the other document is for, in my opinion.
Yes.
No, but there'll be interactions. And should we consider those interactions at all in the primary document?
No.
No.
Thank you.
Right.
All right.
Okay, all right, let's do our hums.
MCQs,
We're over
MCQs,
time.
go quick, go quick.
Okay, if you support option A, please hum. Ian, do it to...
Yeah, seriously.
It's B?
Seriously, Ian.
Do you not understand it seriously?
We are 5 minutes over now, and I asked for 1
We don't
minute
have
if
time.
things
I'm
were
sorry.
going well, and 3 minutes if they weren't.
Okay.
We need this. We need to know what we're looking at walking out of this room, plus the conversation on the mailing list after.
Aaron wants to say the audio died for the remote people, right? Or is there something else?
No, I'm getting hums. I'm waiting for you to call the
Thank
hum.
you.
I'm gonna-
If you support option A, please hum now. Okay, that's enough. Somebody's really good
lungs,
at that.
guys.
That's amazing. Okay, option B, if you support option B, please hum now.
Yeah, that is louder.
Wow. And a nice sustainment. That's really good.
There's 6 additional folks on Jabber who are humming for B.
For B, thank you.
None for A.
Thank you. And finally, if none of those is satisfying and you think that we don't know yet or we need to do something else, option C, please hum now. Okay, that's really great. Thank you, working
All
group,
right.
so much. So we have a path forward for the spin bit. Of course, we're going to have another lovely conversation, probably in Bangkok. So
Yeah. So
thank you all.
I would like to thank you all, especially as the responsible area director. Thank you all.
B.
consensus for B was the result.
Yes, B was a very strong hum. You happy?